Top 10 interesting facts about black holes. You could think of black holes as enormous creatures that continue to expand and eventually consume the entire universe. Black holes do not, however, continue to develop indefinitely because they continually release radiation, which causes them to evaporate. In honor of its discoverer Stephen Hawking, this radiation is known as Hawking radiation. A black hole's evaporation will take longer the larger it is. Even though small black holes disappear more quickly, the process is still too slow to be seen in one lifetime. However, this does not preclude black holes from growing to astronomical sizes. Some of them are actually larger than our entire solar system. Here are 10 more fascinating black hole facts. But before we begin, please subscribe to our YouTube channel for such amazing and informative videos. 1. In theory, anything can develop into a black hole. According to what we currently understand about physics, anything can develop into a black hole. Theoretically, if something could be shrunk down far enough, all that compressed matter would become extremely dense, giving rise to a black hole. Black holes are actually known to form when stars that are 20 to 30 times as massive as our Sun experience gravitational collapse. The Space Telescope Science Institute estimates that 1 in 1,000 stars have enough mass to develop into black holes. 2. Black holes are prevalent in the cosmos. The mere possibility of a black hole is unsettling and mysterious enough. Even just the potential existence of a black hole is unsettling and enigmatic. NASA estimates that the Milky Way, our galaxy, may contain between 10 million and 1 billion stellar black holes. And that only includes our galaxy, one of more than 100 billion galaxies in the universe. 3. Black holes weren't discovered by Albert Einstein. Contrary to popular belief, black holes weren't first discovered by Albert Einstein. They do exist, as his theory of general relativity predicts. Carl Schwarzschild, a scientist, used Einstein's equations and theories to demonstrate the reality of black holes. In 1915, the same year that the theory of relativity was published, Schwarzschild accomplished this. A black hole's Schwarzschild radius, in astrophysics, is the minimum size at which an object must be compressed to form one. But prior to Einstein and Schwarzschild's observations, other researchers made hints about the possibility of black holes. John Michell, a British polymath who predicted the existence of dark stars with large masses, is one such instance. And their gravitational pull was so intense that not even light could escape. In 1967, these dim stars were given the scientific name of black hole. 4. There might be a counterpart to black holes. Black holes are the core remains of shattered stars that absorb all the matter in their immediate vicinity. They are the vacuum machines of the cosmos, and their functionality may very well be good. So many other celestial objects would be in danger because of the excess matter floating around in space as a result of supernova explosions or other events. This is because collisions between other objects and the remains of other planets and stars are very likely to occur. For this reason, black holes and their capacity for sucking matter may be advantageous. Many contend that white holes exist as well but serve a different purpose. Unlike black holes, which absorb matter, white holes release matter into the universe. A white hole cannot be entered if a black hole can be entered. Black holes in general become even more intriguing if white holes, which many people believe exist, are confirmed to exist. Who entered this cosmic conflict first? Do matter-sucking black holes eventually spew it out somewhere else? Or did white holes exist first, and black holes developed as a response? 5. Compared to regular stars, black holes are more effective at generating energy. Nuclear fusion is a major source of energy for stars like our Sun. As several light atomic nuclei join together to form a single, heavier one, nuclear fusion transforms about 0.7% of mass into energy. However, because of the disk of material that orbits around them, black holes are 9.3% more efficient than stars at generating energy. The material on the inner edge of the disk that is closest to the event horizon will orbit at a faster speed than the material on the outer edge. The reason for this is that the closer you are to a black hole, the stronger its gravitational pull becomes. Since the matter is orbiting and moving rapidly, the materials heat up to billions of degrees. This procedure transforms mass into energy. The method is called blackbody radiation. 6. Falling into a black hole is not something you want to do. Do you know what spaghettification is? If you get sucked into a black hole, this could happen to you. Even though the name is absurd, the way it actually operates is horrifying because of the way gravity functions. Even though the name is absurd, the way it actually operates is horrifying because of the way gravity functions. Your feet will be stretched first as you are drawn in by gravity close to a black hole. given that it is further from the black hole's nucleus. Your upper body will literally stretch into a long spaghetti-like strand as the upper portion of your body is sucked in as well, albeit more slowly. 7. Black holes can combine and grow larger. Galaxies frequently combine and become more noticeable as a result. Black holes, however, behave in the same way when this occurs. Many people think that such collisions lead to supermassive black holes. The Andromeda Galaxy and the Milky Way are currently heading toward one another. The supermassive black holes at the centers of the two galaxies will combine to form a single, even more massive black hole when they merge in about 4.5 billion years. 8. The center of the majority of galaxies is a supermassive black hole. Sagittarius A is the name of the supermassive black hole that sits at the heart of our Milky Way. It is roughly 5,000 light-years from Earth. Andromeda, one of the nearest galaxies to our own, also has a supermassive black hole at its core that is about 100,000 times as massive as the Sun. The same scenario frequently appeared in numerous other galaxies that researchers examined. The centers of the majority of galaxies frequently contain supermassive black holes. 9. Close to a black hole, time slows down. The effects of black holes on time are one of their most perplexing features. The general relativity theory of Einstein states that time actually slows down close to a black hole. The term gravitational time dilation refers to this phenomenon. According to the theory of relativity, time moves more slowly for you as you move faster. The strong gravitational pull that would cause you to move so quickly as you approach the black hole's event horizon would slow time itself. It would seem to someone outside the black hole that time has stopped for you. But in the 1 second you have left before all the light goes out, you could turn around and see the outside world moving at a fast pace. 10. The 3 layers of black holes. An examination of a black hole would reveal 3 layers: the singularity, the inner layer, and the outer layer. The boundary surrounding the black hole's mouth is known as the outer event horizon, which is the topmost layer. Because of the weak gravitational pull in this area, objects can still escape black holes. The inner event horizon is the term used to describe the inner layer, which is in the center. Even light cannot evade this gravitational pull because it is so strong. When an object reaches this layer, it starts to fall toward the black hole center. The mass is primarily located here. Even more gravitational pull is present at the singularity, the center of a black hole. Did you learn something new about black holes that you didn't know before? We hope you did. So, if you're interested in learning more amazing ideas, make sure to subscribe to our YouTube channel and hit the bell icon to get notified by our new videos. Please like and share the video. Don't forget to comment down your views on this. Thanks for watching till the end.